Did NASA really just fly a spacecraft into the sun's atmosphere for the first time ever? We will be telling you all about it in today's video. NASA, an organization that has been leading space research for years, once again did the unimaginable. So what spacecraft did NASA use in this expedition? What was the end goal of this launch? And how did they manage to get into the solar atmosphere safely? Stay tuned because we will be telling you all about it. NASA has been the organization that has led humanity to its many firsts. Right from the first time we landed on the moon to the first craft that managed to fly outside our solar system, NASA has got its name sealed in many records, and they have one more to be added to the list. Humans have finally made a spacecraft that has touched the sun for the first time in history. NASA's Parker Solar Probe has now gathered particles and magnetic fields in the sun's upper atmosphere, which is known as the corona. This latest achievement of NASA may be one small step for the Parker Solar Probe, but it's one giant leap for solar science. Collecting the same stuff the sun is made of will help scientists discover crucial knowledge about our nearest star and the influence it has on the solar system, just as stepping on the moon allowed scientists to determine how it was formed. Fun fact, the Parker Solar Probe is also, to date, the fastest ever spacecraft created by humans. It was recorded flying towards the sun at a maximum speed of 430,000 miles per hour. Moving on, the Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington, Thomas Zurbuchen, stated, "Parker's solar probe touching the sun is a monumental achievement for solar science and a truly remarkable feat." He further commented, "Not only does this milestone provide us with deeper insights into our sun's evolution and its impacts on our solar system, but everything we learn about our own star also teaches us more about stars in the rest of the universe." Parker is discovering new things that other spacecraft couldn't see because they were too far away, such as new findings inside the solar wind, which is the flow of particles from the sun that can influence us on Earth. According to Parker, switchbacks or magnetic zigzag patterns in the solar wind are widespread near the sun. However, how and where they formed remained a mystery. After decreasing its distance to the sun, the Parker Solar Probe has finally traveled close enough to identify the solar surface. The first flight into the corona, and the guarantee of many to come, will continue to transmit information on processes that are difficult to examine from afar. Scientist Noor Rawafi of the Johns Hopkins Physics Laboratory in Maryland said, "Flying so close to the sun, Parker's solar probe now senses conditions in the magnetically dominated layer of the solar atmosphere, the corona, that we never could before. We see evidence of being in the corona in magnetic field data, solar wind data, and visually in images. We can actually see the spacecraft flying through coronal structures that can be observed during a solar total eclipse." Parker's Solar Probe was launched in 2018 with the goal of digging deeper into the mysteries of the sun by flying closer to it than any previous spacecraft. Parker has finally come to the surface 3 years after its launch and decades after its creation. The sun, unlike Earth, does not have a solid surface, although it does have a superheated atmosphere made of solar material that is magnetically and gravitationally bound to the sun. Increasing heat and pressure force the material away from the sun to the point where gravity and magnetic fields are not strong enough to keep it in place. Think about it this way. When you keep a balloon on the ground with the help of a rock, that rock holds the force to retain it. But if there's a strong pressure applied to the balloon, then it will manage to escape the force of the rock and subsequently fly away from it. In the same way, these particles, due to a certain pressure, manage to escape the force of the sun or the rock. The ending of the solar atmosphere and the beginnings of the solar wind are marked by that point, which is called the Alfvén critical surface. The solar wind is created when solar material has enough energy to break beyond that limit, and it carries the sun's magnetic field with it as it accelerates across the solar system to Earth and beyond. Until now, no one knew where the Alfvén critical surface was located. The corona is estimated to lie between 4.2 to 8.5 million miles from the surface of the sun based on remote views. However, with the readings from the Parker probe, a more accurate distance is being measured. Parker's solar probe encountered certain magnetic and particle conditions at around 8 million miles above the solar surface on April 2021 during its 8th flyby of the Sun, indicating that it had managed to cross the Alpine critical surface for the very first time and finally entered the solar atmosphere. Parker's solar probe flew into and out of the corona many times throughout the flyby. This shows that the Alpine critical surface is not shaped like a smooth ball, as some had assumed. Instead, the surface is wrinkled by spikes and troughs. Think about the surface more like the body of a porcupine instead of the shell of a turtle. These readings will help scientists figure out how the Sun affects the atmosphere and solar winds. As the Parker Solar Probe approached 6.5 million miles from the surface of the Sun, it went through a structure in the corona known as a pseudo-streamer, massive structures that rise above the Sun's surface and can be seen from Earth during solar eclipses. People inside the NASA control room said that this experience of the Parker probe entering the solar space was nothing short of flying straight into the eye of a storm. The mission's initial corona crossing, which lasted only a few hours, was the first of a series of scheduled crossings. Parker will continue to spiral closer to the Sun until it reaches 3.83 million miles from the surface. During future flybys, such as the one scheduled for January 2022, the Parker Solar Probe will almost probably pass through the corona. Now, before we go on to tell you some of the other discoveries made by the Parker Solar Probe, we would like to thank you for successfully making it till here. You can extend your support by subscribing to the channel and liking the video. Now, let's continue. Some unexpected physics surfaced even before the first pass into the corona. Parker Solar Probe collected data from the origin of zigzag-shaped structures in the solar wind known as switchbacks during previous solar encounters. According to the data, the photosphere, which is visible on the Sun's surface, is one place where switchbacks originate. The solar wind is an unstoppable headwind of particles and magnetic fields by the time it reaches Earth, 93 million miles distant. However, the solar wind is unorganized and uneven as it escapes the Sun. The NASA European Space Agency mission Ulysses has flown over the Sun's poles in the mid-1990s and observed a number of strange S-shaped bends in the solar wind's magnetic field lines, deflecting charged particles on a zigzag course as they fled the Sun. For decades, the scientists assumed that these irregular switchbacks were unique to the polar regions of the Sun. Parker discovered in 2019 that switchbacks in the solar wind were not uncommon, but relatively frequent. This sparked people's interest in the features and led to more inquiries. What were their roots? Were they created on the Sun's surface, or were they shaped by a mechanism that twisted magnetic fields in the solar atmosphere? While the mysteries of the Sun are getting figured out by scientists, we would love to know what you thought about the Parker Solar Probe. Let us know in the comments below. And again, thank you for watching. We'll see you next time.